All right, let's try to figure out what we need to know about water for this test. Okay, we got 5 questions, and these questions we will have them show up again at the end of the video, so you can try to answer them all for yourself and see what we've learned and remembered, or if we forgot anything. What are the 5 main functions of water? Yes, that's an important question. What involves movement of the solute from areas of higher to lower concentration? Yes, that's a common question. Uh, Difference between latent heat of fusion and latent heat of vaporization, along with high heat capacity is another big one. Compare and contrast sublimation and deposition. And then finally, water is both cohesive and adhesive, and we want to be able to explain that, what that means. Okay, so this here is a look at a polar covalent bond. So probably obvious, but just to start, in a water molecule, there are 2 atoms of hydrogen, 1 atom of oxygen. That makes our H2O. A water molecule is an example of a polar covalent bond, which is what we're looking at here. The electrons are unequally shared, with the oxygen atom spending more time with the electrons than the hydrogen atoms. Since electrons spend more time with the oxygen atom, it carries a partial negative charge. A nonpolar bond, on the other hand, involves electrons being shared equally with the molecule. A covalent bond occurs within water molecules between hydrogen and oxygen. Hydrogen bonds occur between water molecules. Water molecules form a hydrogen bond, which is a type of intermolecular force, with electronegative oxygen atoms of other water molecules. Molecules that are polar will dissolve in a polar solvent, like water. Glucose has many polar OH groups that can form hydrogen bonds to water. The water molecules are attracted to the glucose as strongly as they are attracted to each other. Glucose can easily get between the water molecules, so glucose dissolves in water. A molecule like cholesterol consists almost entirely of nonpolar CC and CH bonds. Gasoline and methane are also nonpolar and will not dissolve in water. So the 5 main functions of water, so that was one of our questions, right? What are the 5 main functions of water? Very first one. So the 5 main functions of water are cell life, transport, chemical reaction, temperature regulation, and waste excretion. So that's something we just want to commit to our mind are these 5. We need to have them uh, locked in. And while this is not a part of the slide, a question that often does show up on water and is occurring to me is blood is 92% water. The human body is 60% water. So having those numbers, I don't know that you necessarily need to know 92, but that it's somewhere around 90 as far as blood and water. Okay, diffusion and osmosis. Diffusion involves movement of the solute from areas of higher concentration to lower concentration, while osmosis involves movement of the solvent from low to high concentration. So, questions? What involves movement of the solute from higher to lower concentration? And that would be diffusion. Osmosis is a specific type of diffusion. It involves migration of the solvent rather than the solute, and it is a process utilized by the kidneys to maintain proper water balance. Okay, and as we jump into what we're just generally calling heat, so we want to know about the latent heat of fusion, vaporization, as well as high heat capacity. These are commonly tested concepts. The amount of energy needed to melt the ice after it has reached melting point, that's the latent heat of fusion. While the amount of energy needed to boil all of the water into steam is called the latent heat of vaporization. Water has a high heat of vaporization because hydrogen bonds form readily between the oxygen of one molecule and the hydrogens of other molecules. These bonds hold the molecules together. To get water to vaporize, you must increase the temperature to make the molecules move faster. The fact that water requires more energy to raise its temperature is a reference to its high heat capacity, but not to high heat of vaporization. Water also has a high heat capacity, meaning it takes a lot of energy to change its temperature. This makes releasing warm water the perfect way to cool off. That's why you sweat. When the water evaporates, it takes its stored heat with it. It also makes it harder for the environment to cause your core body temperature to change. All right, so those are three big concepts that we want to know about. And then we have sublimation and deposition with smaller text for some reason. During sublimation, a solid that is at a temperature and pressure below its triple point, which is the point at which temperature and pressure reach an equilibrium so that the solid, liquid, and gas of a substance can all exist at the same time. So when a solid is at a temperature and pressure below its triple point, which we just discussed, it turns directly into a gas when enough heat energy is applied. While deposition is really the opposite of sublimation, a gas that is at a temperature and pressure below its triple point turns immediately into a solid when heat energy is removed. And then finally here we have cohesion and adhesion. And if you remember, I think this was our last question. Okay, so cohesion is the tendency of similar particles to cling to one another, while adhesion is the tendency of non-similar particles to cling to one another. A water molecule, which again, two hydrogen atoms and one oxygen atom, is polar. Since polar molecules are attracted to each other, water is cohesive. This means it holds together very well. And this really means that water does not require much energy to be pumped from one place to another. Water is adhesive because the polar molecules of other substances in water are attracted to water molecules. And while not on this screen, you could see a question about cell life. Cell life is based on the fact that cells have water inside them. Water is used to transport nutrients to cells and within cells, meaning it's intracellular. If cells don't get nutrients, including vitamins, minerals, and sugars, they will die. That's cell life. Okay, and then we jump back into our questions. So that was a action-packed video with lots of stuff to remember. So this is a chance to test yourself out on what you just learned and see if you can answer these questions correctly.